Okay, it's 1:03, so I think we can start. We are very fortunate to have Dr. Skalk Skuman presenting today. Skalk, without further ado, please take it away. Thank you.
Many thanks, Elrisa. Yeah, thanks for Elrisa and for CropLife for inviting me. I tackled the first one, which is both easy and difficult. So you can see management of the nut borer complex. Let's leave the other pests out of that. It's just nut borer, there's quite a number of them, as you will see as we carry on. And I say it's difficult because you'll see that the situation is not easy, and it's easy because we have a lot of products available for the management of the nut borer. Let me just move down. Yeah, I think all of us in the pesticide industry at the moment are painfully aware that many things are changing, and yeah, first and foremost of that is it's an aspect that was highlighted in 2017 by some German scientists, where they reported on the losses of not just biodiversity but also biomass, which really shook the world at that stage, and it has led to some changes in how we approach agriculture and a number of other things as well. The global climate change is not global warming necessarily. Climate change debate is hotly ongoing, and it probably will happen for many years to come. And we know that internally there are some changes in the pesticide industry and as well. Yeah, and then probably last but not the least is political and global instability due to wars and a great number of elections that are currently being held this year, as we are painfully aware of. And with all that in mind, I think I'm going to focus mostly on macadamias, but I will reference from time to time to other crops as well, because we've dealt with them as well. And with all that in mind, for the mac and also for the other industries, I think the sustainability of crop protection is going to be a very important factor. Us sitting here in Africa have to deal with a lot of indigenous pests that do not occur elsewhere. Hence, we have to find solutions for these guys locally. We can't look north for solutions. What I aim to do with the talk is just to give you a bit of background on the life cycle of these insects. And I say insects because we're dealing with a group of them. It's not just one nut borer. The idea is to know a little bit more about them and to know where the weak spots are, so that we can exploit that. And the timing and the how is going to be very important. Secondly, I think I'm probably preaching to the converted, but if you speak to the farmers, they do have I think we can help them with a bit more knowledge about the pesticides that is currently available. What is the characteristics of the pesticides, when to use it, where to use it. And then again, last but probably one of the more important aspects is to look at the non-chemical or non-pesticide options, parasitoid releases and mating disruption, and just to give a bit of guidance as to how and where one can and should use these tools. And this is now my mantra. There are only 3 reasons why a product shouldn't work or should work. First, we need the correct product, and it has to be properly applied. And then lastly, it has to be synchronized with vulnerable stages in the biology of the insect. And if you have all three of those sorted, one should get good control of an insect. And if there's a product failure or a supposed product failure, one can look in either of these three options, and one should find the reason why the product is not working, or the treatment protocol. Without further ado, I'm going to kick off with the biology of the insect, or the insect complex, because we're not dealing with a single. In macadamias, we're definitely not dealing with a single pest species. We are dealing with a whole range of them. First and foremost is a false codling moth. Just earlier this year, I visited Zambia, where false codling moth is by far the majority of the problem. In actual fact, I've never seen it in mealies. I've seen false codling moth eating seed maize and causing quite a bit of harm. So up north of our borders, false codling moth is a serious production constraint, not only for macadamias and other crops, avocados. It's a big issue, and it's something that we will have to deal with year after year. Our friend the macadamia nut borer, we name it the macadamia nut borer, but as we carry on, we realize that this guy is more it's slowly expanding its range, and we're finding it now on citrus, and we're also finding it on avocados, and I'm pretty sure we probably will find it in other crops as well as time goes on. When I was working at ARC, there was a lot of lychees on the farm, and the lychee moth has played a major role in the macadamias on the ARC farm. I'll refer to a study that was done by a student of Pot University, Marnus Enselen, a master's study. And Marnus has also found the lychee moth in Barberton, where he did his study also in macadamia. So it definitely does not limit itself to lychees, but I think it also has a wider host range. And then there's a range of other moths. As you can see there, these are just 4 of them. There are actually a few more. A carob moth, Lobesia vanilliana is one that we know, and I am not even going to try and Sidargerutus. I'm not even going to try and pronounce that one. And then Coristunera occidentalis, all having the potential of becoming big, on its own right, being problematic. I think everyone knows the life cycle of the insect. But before I say that, let me carry on. I'll talk a little bit about the species complex at a later stage. The life cycle, I think everyone knows the story. Female moth lays the egg on the nut surface. Interesting enough, you can see in that graph on the top left, that picture on the top left, the red circle, that's where the egg was laid. They always laid on, not always, but most of the times laid on the suture line where the nut is going to split open when it dries out, or when it becomes more mature. My reasoning here is that somehow these moths can smell that there is probably going to be it's going to be easier for these larvae to penetrate the husks. And in many cases, and I've taken quite a number of nice photographs where the eggs are actually laid in a neat little row all along the suture line. Definitely something in that. The yellow circle is where the neonate, the larvae has penetrated the husk, And that also points to the challenge that we face with chemical control. So that neonate larvae will have to pick up enough chemical residue crawling from where the egg was deposited to where it actually penetrated the husk to be lethal. And if one spray a dense orchard, you know, it presents quite as quite a challenge. When the shells are still soft and developing, you can see the second slide in the middle top. These larvae then can penetrate the shell, and on the top right hand side you'll see what happened to the kernel. It simply devour the kernel and turn it into powder. Around about mid-January, the shells become hard, and larvae cannot penetrate the shells anymore. And if you look carefully, let me move the cursor. You'll see that those sort of shallow grooves or bite marks in the shell. That normally is also an indication that they're there, but they cannot penetrate the shell. If you look then at the middle of the bottom line of the bottom picture, what happens then is that these guys simply feed on the tissue inside the husk, and in so doing, they just cut off the water in the electricity of these nuts, and they either drop to the ground or continue to hang on until harvest, all depending on when and how much damage has been done. These nuts usually turn out to be immature because the vascular bundles that nourish the nuts are then severed or greatly reduced. Once the larvae are mature, fully grown, they feed. If you can see there on the bottom left, that's emergence hole. And they descend to the leaf litter to pupate. They normally use the silken thread, but not always. In some cases, you'll see the cocoons sticking out, sort of partially sticking out of these emergence holes, and we do get pupation sometimes in the nut. It's not common, but it can happen. Just more pictures of the same. Top left, you'll see that's the pupae. The one on his right, the emergence hole, that's a mature macadamia nut borer. Problem is the immature stages on the top right. They all look pretty much the same. There are macroscopic differences between the larvae. Between some of them, we can differentiate. We don't need to do molecular identification, but if they're still young, unfortunately, molecular identification is the way to go. On the bottom picture, there's just a parasitized egg. I will show you some more when we go to the section on parasitoids. When you look at the life cycle through the development of the macadamia nut, it always follows the same pattern, and it's not just macadamias, as you will see. So early in the season, during the first couple of weeks, very low infestation on the macadamias. Although this graph doesn't show it so nicely, we normally see a very big change around about here, week 9 to week 12, where we start picking up a greater incidence of eggs being laid on the nuts. The reasoning here, and so far it seems to hold quite a lot of water, is that when the fruit, not just macadamias, other fruit, as I will show you now, are going through the initial phase of early abortion of the fruit, or early thinning of the fruit, that somehow these insects can smell that the fruit are probably predestined to abort, and they do not lay eggs on them, although there are sometimes moths available. And in Marinus' thesis, he has had graphs with the moth flight peaks during this time. So yeah, so they don't lay eggs, and the idea is that I think they can sense and smell when that these fruit are in the process of thinning, and if the fruit is going to fall, so is the young larvae, and they won't complete their development on a small fruit lying on an orchard floor. The moment that period is finished, we do always get this really rapid upward increase in eggs being deposited, and as well as larvae inside the nuts. We can carry on and look at lychees, exact same pattern, different moth, lychee moth, mostly lychee moth, although in lychees false codling moth do occur, but in low numbers. Ignore the yellow line; it's just a fruit mass. But yeah, have a look at the bar. Same thing. Very basically no incidence of eggs early in the season, followed by a rapid increase. And then we did the same for Pinkerton avocados in halls, exact same pattern. We're going to get back to that just now. I'm going to refer a lot to this article. It came out this year, and I can forward it to you if you are interested. Please just leave your particulars with El Riza or with myself, and it's quite an interesting article. I do think that Marinus Enslin has done some groundbreaking work. I'm not slides. I'm going to show you one slide that I took from his work. But where in macadamias we always worked on the premise that we are dealing with macadamia nut borer throughout the season. I think Marinus has showed us that it's really not the case. And before I carry on, I'm just want to reiterate that he did this work on one farm in the Barberton area, and I think there's a critical need that this work now has to be expanded to other parts of the production regions as well, to see what the situation is. But looking at this graph, the numbers here in the bottom is the Julian calendar. In other words, week 43, 44, and then week 1 is the first week in January. The blue lines, the blue bars there is false codling moth, and sort of the brownish ones is macadamia nut borer. As you can see, early in the season, majority of the larvae that we did encounter, or that he did encounter, were macadamia nut borers. But if we reach towards the December period, slowly the false codling moth took over and remained the dominant pest throughout the season. Now, this is the case on one farm, and I'm pretty sure that we will probably find a different situation on other farms. And I think it's pretty important that we understand why certain moths are dominant in certain times of the year, and also in various regions. Although we didn't look carefully at it at this stage, I think in future studies one should. Barberton's quite a cold area. We don't think it is, but where this farm is situated, it's quite a cool area. will this play a role in giving one species the upper hand above the other one? We simply don't know. We don't have enough data at the moment. Yeah, this I regard as groundbreaking work in the sense that if you want to use pheromones, we all know pheromones are species specific, and we really have to use the correct product at the correct time. And I think this points to what we all have assumed in the past, and this is that the situation as far as the species complex of these moths are concerned is not straightforward. It's definitely it requires, my honest opinion, is a significant amount of study before we have sorted this out completely. Length of the life cycle. At this moment, we're battling to breed macadamia nut borer in the laboratory. It's not an easy insect to breed. Tortricidae moths usually are not. We've done that with a lychee moth at the ARC, and we know it's not a simple process. It's going to take time, but in the end, I'm sure that the people that are busy with the breeding program at the moment will succeed. Just having a look at the false calling moth, this was studied in detail in the past. There's a pre-oviposition period where the adults, after they've hatched or if they've emerged from the cocoon, for about 5 days where they don't lay eggs. Just remember this figure. I'm going to come back to this later. There's 456 eggs. Moth has a lifespan of 2 to 3 weeks, and the duration of the life cycle can vary significantly. I looked at various publications, and you can see there 152 days in nature. That sounds a bit too long, but it was nevertheless recorded in one of the old papers. I think the 25 days is probably closer to being realistic, especially if you look at the figure of about 33 days for the macadamia nut borer, just below that. So yeah, just give you an idea how long these moths do last. We then did a study during 2021 and 22 when I was at SAMAC, just to work out what is the impact of these moths in the area. Did about 20 farms. The number of orchards was 18 farms each. Evaluated in both years 9,000 nuts, so it was fairly comprehensive. And if you look at the figures, average infestation, it would occur that it would appear that the damage is becoming worse. I honestly do not think so. I think it's just the farms that we selected. But what I would like to show is the bottom two lines, the 3 worst performing farms. Looking at average of about 20 to even 35%, which is extremely high. But the most important one is the bottom one, and the 3 best performing farmers are really sorting it out and really getting they're using the tools that we do have to sort out the situation. Just before carrying on, I'd just like to mention that this study was done during about a 2 to 3 week period, and only on the cultivar 816, in order to minimize natural variation as much as possible. So yeah, so I think while some guys are battling, I think there's definitely the guys that are winning the battle are doing pretty well. Yeah, but I think this is not a simple insect to deal with, because there's there's many things that do play a role, and one of the important things is that only eggs or newly hatched larvae can be controlled. So once that young larva has tunneled into the husk, there's very little that we can do at the moment with the means to our disposal to control these insects. I'll show you now that, and you've seen the graphs that I showed on the population, the curves, that early in the season, when you do see that sharp upward spike in the graph, that oviposition during that stage is very, very synchronized, and that is the ideal time to apply a pesticide to have the biggest bang for your buck. But I say there's a proviso: the spray application must be very close to perfect. And I'll show you some data. I've showed this in the past, as that these moths prefer to lay their eggs deep inside the tree canopy. So pruning is therefore a very important aspect if you want to succeed with chemical control. Pheromones has been out to monitor male flight peaks, and in the past we said no. The link between male moth flights and females actually depositing eggs is not great, but we've seen that if you do a 3-week correction with the male fly data, that we can get a fairly accurate prediction of when the eggs are being laid. In other words, if you do pick up a male flight peak in late November, you know around about three weeks later, you will get an oviposition peak. It's a bit more work needed for this, but there's a great promise that this could work pretty well. I was a proponent for monitoring for eggs in the tree canopy until I started doing it myself. It's not easy. The problem here is that you do find a lot of negatives. There are a lot of nuts without eggs on them. So not an easy way to monitor. But yeah. And out of all of this, it's very clear that once November dump is completed in macadamias, it is probably the most ideal time to apply a chemical spray. And the next graph will actually highlight this aspect very clearly. This was a study that was done just outside Nelspruit. You'll see what happened to this orchard is it's situated close to the Croc River. There was a lot of frost, and the flowers got damaged, and so there wasn't much of a crop in the orchard. So instead of the farmer normally sprays 4 times for these moths, methoxyfenozide, emamectin, benzoate, alternated between the two of them. And in the orchard that was damaged by cold, the farmer didn't spray the November spray of methoxyfenozide, and you can clearly see the difference. Although even with 4 sprays, the damage of 20% is high. It's nothing compared to the nearly 70% damage where the late November, early December spray wasn't applied. So clearly, this is the critical time for nut borer spray. I've shown this in the past as well. We've done this work in Barberton, where we measured a couple of things: nuts with eggs, number of eggs on the nuts, and then the number of larvae in the nuts. We used nuts on the outside of the tree, next to the working row, and then nuts as deep as possible into the tree. I can see there in the Barberton survey, there were huge differences. I mean, look here at the number of eggs, 15 the outside versus nearly 90 on the inside. So yeah, our thoughts immediately went to that it's a function of spray deposits, that you do get more effective spraying on the outside than deeper inside the tree. And then we did a second survey in Nelspruit on Nelmax, where the trees were very dense and also very open in the bottom. So the spray penetration shouldn't have an effect in that case. This orchard wasn't sprayed with chemicals at all, and then you look at the same scenario. The differences were not as big as in the Barberton survey, but it was in all cases statistically significant, and it was about double the amount of damage deeper inside the tree. Now this clearly points that if we are going to spray a chemical, that we will need a spray penetration as deep as possible into the tree. And the trick here is not to get runoff of products on the outside on the part of the nut facing towards the outside, while you still get a covering on the nuts facing to the main stem of the tree. In other words, to the deeper inside part of the tree. Yeah, so this is a difficult part. We then had a look at the at biocontrol, and in the past we were not really giving much attention to this. I went through literature and did a look, see how many beneficial insects are there on the pest complex, and I came across all these guys, at least 12 different species that do affect the complex, and very often, and I've done this work for stink bugs, but I haven't really did the calculations for the nut borers. But remember that figure I said earlier of 456 eggs. So I started with the assumption, we have one female, there's no natural mortality, and then I sex ratio of 1 to 1, and then I had a look at what happens after 4 generations. So modest second generation, we end up with 228 females. After the second generation, about 52,000. And then after the third generation, and just a tad under 12 million insects, with about 5 billion insects after the fourth generation. Now, clearly, this doesn't happen. Otherwise, we would wade through moth eggs all over town. And the reason for that is that natural control, controls a great majority of these eggs. I think there's a lot of things one can say, a lot of things about biocontrol, and in time we will devote a similar talk, more into the intricacies of biological control. I just want to leave a very, very cryptic message here, that there are different types of biological control. Classical control is what SAMAC currently is attempting to do with the felted cosset. The pest was introduced into the country without its natural enemies, and we are bringing in, or they are bringing in, a parasitoid. It will be released in the production regions, and the idea is a single release should suffice, and it should control the pest insect. We do get inoculation, and this is where we release smallish numbers of parasitoids, not pesticides, as I wrote there. early in the season, and then augmentation. This is where we release large numbers of parasitoids during the season, and this will function then basically the same as a pesticide application. I think it's important to know that parasitoids do regulate their host numbers in a density-dependent fashion. In other words, if the numbers of your pest insect increase, it will spark a concomitant increase in parasitic numbers as well. Normally, your pest insect will, obviously your pest insect population will increase first, followed by by the parasitoid, and then if numbers are high enough, you will get you could get damage in the tree. This is why you do the augmentation of all the inoculation, and to prevent this situation. Insecticides can be used with circumspection in the orchards. Remember, these are insects. They are tiny. Because they are small, their relative outside surface area to their volume is actually pretty high. In other words, they're going to need a very small amount of pesticide to be killed. But also remember that that although a spray will probably kill a lot of the parasitoids flying, the adult parasitoids flying out in the orchards, it will not, or it will in most cases not control parasitoids living in the egg or living within the host of the parasitoid, provided that the pesticide that you did spray has a short enough residual action. And for this reason, I think it's pretty good advice not to spray 2 or more broad spectrum products in close to each other, as you would then wipe out more than one generation of the parasitoids from the orchards, and you are going to start creating voids. What is important for the false codling moth and the kin, Macadamia nutborer, lychee moth, and so on, is that Trichogramma toidea, the parasitoid, the moment it deposits their eggs in the embryo or the developing embryo of the host egg, the parasitic embryo splits in 3. And if you look at the right side there, you'll see the 3 little emergence holes of these parasitoids. So yeah, I'm not going to say more about the parasitoids. We have released it in last season in Nelspruit area. We have released it in combination with methoxyfenozide spraying, and it was really very effective. We really did control the moth numbers very efficient. So this is something that makes me at this moment very excited. I think it's something that is of practical value to farmers, and currently can be used with great effect. What is important is that we sit with another tool that is currently not functioning as good as it could. Mating disruption is extremely important, and Tortricidae moths are normally very susceptible to this kind of control. Yet the last couple of years we have experienced problems. And as I've mentioned before, the life cycle of these insects are not simple. It is complicated, and I'm going to look a little bit deeper, and because mating disruption is a very valuable tool in the toolkit, and as you see there in the bottom, it does integrate extremely well with the releases of your trichogramma wasps. So it's in all our best interests that we do sort this aspect of control out very well. Okay, the first thing that one can imagine is that we're dealing with more than one species. And you've seen the work of Marnus. It seems that the species do succeed each other throughout the season, which really complicate the use of these products. The question that's asked is this true for all farms or just for that region? It's a very valid question, and it's one that should be answered by research, and it should be a high research priority. One of the things that I did found last season, we did find that during the second part of the season that gravid mated females did fly into the orchards during the second part of the season. And if this is the case, if there's sufficient host plants surrounding the orchard, then mating disruption probably will not prevent will not prevent them from flying in. I mean, they already mated outside, so this could be a problem situation. It will not be the case in all the farms, but it needs to be determined on a farm-to-farm basis. Interesting enough, when one look at macadamias, and when you look at avocados in a country like Zambia, or even citrus in South Africa, that mating disruption is still a very valuable product. A valuable tool in the toolkit. So clearly, you know, there's a bit of fine tuning that needs to be done, and I think this is a very valuable part of IPM that we must really give a lot of attention to. I'm not going to say more about that. I've dealt with this approach over the years quite a lot, and I just maybe gave some advice, you know, as what we must do if we want to use this more properly in future. Firstly, I think it's important for each farmer to evaluate. For those that are not really, I think most people are doing it, but it does take in a bit of effort to work out exactly in the last part of the season how much or how many nut borers are there. You're not going to see these figures in the factory report, and so the only way to do this is a bit of number crunching in the field. Pick up the nuts, see how many nuts are laying on the ground, work out what is the infestation levels of these guys in an orchard, and then I think it's then if you know what that figure is, then you know exactly what type of control or how much money you can spend on control, and that will determine obviously what type of control one can use. Secondly, and probably just as important, is to look at the species that are involved. There are ways to do this at this moment. FOBI has the facility and they have the expertise to do to work out, to determine that genetically. It may be a suggestion to send samples during January, February to them to make sure what species are involved. Ideally, one would like to repeat Marnus's study and do a season-long study. But yeah, I do understand there is limitations to what we can do. Mating disruption, for very obvious reasons, I'm not going to work in windy areas, as the pheromone plume may just be blown out of the orchard. And along the same lines, long, narrow orchards are also not going to work for the same reasons that wind or air currents could move the pheromone plume. The research that we did way back on mating disruption, the guidelines that they provided to us at that stage was the minimum size, orchard size of 8 hectares, not smaller. I must admit, we've pushed the envelope to about 6 hectares, but we haven't gone smaller than that. Bigger is better. Just a quick just a quick one on the biology of the moths and the immigration during the late season. As you can see, when we pick the nuts off the ground, as one can expect, a lot of the nuts were damaged by the borers that fell, and at that stage there wasn't much of a statistical. Although if you look at the differences, it looks as if they were the differences. But if you did the statistics, there were no differences. There's significant differences between perimeter trees and trees deep inside the orchard. But the picture changed very much if you harvested the nuts from the trees. And here there was highly significant differences between nuts on the perimeter and nuts deeper into the orchard, which proves to me that during this was done during January, February, that as the moths fly in, they settle on the edges of the orchard. This is a normal way insects do. Insects react when they move into an orchard. And then lay their eggs, and then slowly move deeper into the orchards. Like I mentioned before, this is a difficult situation for mating disruption if this happens. I'm going to quickly run through the chemical products. I think most of you, it's not necessary, but these are the different chemicals that are available that is registered for macadamias. And the most important things that I'm going to highlight there is just the residual activity, because that will determine if you can release parasitoids and when you can release parasitoids post an application. I went through the literature as much as I could, and also through the internet, and where certain products were used, and where it was the post residual activity was, the post application residual activity was recorded. In the case of the acetamiprid, you'll see there it's about 3 weeks, and it's, although the chances that you will pick up really any bee mortalities if you do spray during late November, early December is very, very slight. It's currently on overseas markets. The effect on bees is still a big thing, so I thought to include that as well. According to the Environmental Protection Agency of America, this product is moderately toxic to bees, and therefore has a low environmental impact if you compare it to other insects. Degrades rapidly in the soil and has a low chance of leaching into groundwater. Acetamiprid and novaluron. Not going to go through acetamiprid again. Just saying that I like the idea of pesticide mixes because you fight resistance and you enhance efficacy. It's interesting enough. Novaluron is an insect growth regulator. In other words, it affects the insect hormone that regulates growth and molting. Residual activity that we could pick up from the internet there was 35 days. They say it's good. This product has good results when applied against susceptible pests. It's greater, much greater. If the older guys will remember the diflubenzuron and teflubenzuron that was used on the citrus, if I believe quite a good couple of years ago, and so it's a good Lepidoptera killer. Acephate, I don't have to say much about. It's organophosphate. They do break down pretty quick. but residues can linger on for quite some time. Acephate does have quite an effect on the orchard ecology. It is a possible human carcinogen, and it's moderately toxic to birds. Interesting enough is that acephate do break down to methamidophos, and which is a highly systemic product. Chlorantraniliprole, 9 to 11 days post-application. The interesting thing about chlorantraniliprole, the product was isolated from a flower, the one there you see in the slide, Rihanna speciosa, very, very toxic to insect. The pesticide that was manufactured from the plant extract was used for a couple of years, but it was quite toxic, and it was discontinued 1996. It's a stomach poison. It has to be ingested, and it's a very safe product. Has no significant acute toxicity, oral, dermal, inhalation routes. Very safe product. It is a diamide. It is also, this group of pesticides is also going to be, I think, if one look at the pesticide industry, one of the insecticide families that will become more used and more prominent in the next couple of years. Here I'm just going to look at lambda cyhalothrin, as every one of us know that it's a synthetic pyrethroid. I tested this product myself on 2 spotted stinkbug, and there we got, I say 3 to 5 days, closer to 5 days control on post-application residues in the field. A very good Lepidoptera killer, Lepidoptericide, but it's quite toxic for honeybees, as one can imagine. Emamectin, translaminar systemic product. Interesting enough, this was also produced by the bacterium Streptomyces albuminellus, and it belongs to the ivermectin family. And it has very, very good efficacy on a range of products. Everyone knows, but the people have even used it for not emamectin, but some of the ivermectins for COVID control. 6 days residual activity post application. It's also a very, very, very widely used Lepidoptera killer. But it is also fairly damaging to honeybees, and also to aquatic invertebrates. In Doxacarp, it was considered as an OP, organophosphate replacement. Fairly short residual period, 1.5 to 2.76 days. Moderate to low toxicity for the environment and for humans. But I came across quite a number of articles where the guys picked up resistance against this product. So if one use it with circumspection, and do not go through the normal routes that has been suggested to limit the buildup of resistance. It is toxic. This product is toxic to bees, but Spinetoram is also one of the I would say it's not that new, but it's a newer product. It's also a fermentation of the soil bacterium. I'm not even going to try, and Saccharopolyspora spinosa. and it's very similar to spinosad that we use for fruit fly baiting. And the same thing, it will give you 2 to 16 days control. And low, not very soluble in water, and it is moderately toxic to fish, but fairly toxic to honeybees. Good product to use. Methoxyfenozide. This is the second product that can influence the life cycle of the insect, the metabolism of the insect, the word I was looking for. It has good control against a number of caterpillar pests, and it also affects both the eggs as well as the larvae. This guy is where the previous one was working on the chitin synthesis, the previous product, you remember. This guy works on the youth hormone of the insect. It's moderately root systemic, not really leaf systemic. It does have a fairly long residual period, 14 to 28 days. And it's a very safe product to use in the environment. With that, I'm going to step off with the pesticides. Just going to focus on the treatment decisions. Again, referring back to the work done by Magnus Enslin. We always worked on the premise that 816, 788, 344 are the most susceptible cultivars, and if one look at his work, that he's found fair amount of infestation in the situation where 816 was interplanted with Beaumont. Yeah, if they found quite a lot of moth oviposition on Beaumont in this regard. I think it's important to measure the economic damage, to know how many of these moths are in the orchards and what the damage is. And the economic damage is simply where the value of the damage caused by the insect population is equal or more than the total cost of the pesticide treatment. So if one then want to know when to control this pest, obviously I have to come in at the stage a little bit earlier, the economic threshold. And to help a little bit with this, we developed this next economic damage calculator that I think will be available to the growers, and I can also mail that. Although I can mail it as it is, but it's not. It's a work in progress. But it'll give you a very good idea. When to apply a pesticide. My first choice would be to apply a pesticide, after the November dump period has come to an end, and then for all subsequent pesticides that has to be applied, if that's going to be the route that you're going to take, one can use this damage calculator. And in the damage calculator, there's also provision that you do set your damage levels at a range of percentages, and then you can react. You can react before you reach economic damage. In this regard, I set it. I think it was at 20%. I think normally if one wants to be accurate, one would work on a figure of 5%. And with that, I'm going to finish off. Just wanting to say that there's significant tools in the toolkit. Some farmers are getting it right, and I think this is one of the easier pests to control, as we have quite a number of options. Life cycle, I'm sure I got the message over. The life cycle is not easy; it's complicated, and I think the most important thing is how we're going to integrate the various options, pheromones with the pheromones and mating disruptions with the releases of trichogramma wasps. So with that, I'm going to finish off. I'm nearly within my hour. And if there's any questions, you're welcome to shoot.
Thank you so much, Skalk. We truly appreciate your time. For anyone who is participating in the CPD program, the assessment is loaded in category 1. I will give maybe just a minute or two, Skalk. We can look at the chat box for any questions. I see we have one from Christine on the efficacy of new virus Multimax, please.
Yeah, Chris said Chris, nee.
It looks like it, yes.
Chris, sorry, Chris. I haven't even tested, touched on the microbial products in this presentation. I know it's a new product that's out there, and with that, there are also other microbial products that are available. So yeah, that's. Thanks for highlighting that. That's an important one.
Thanks, Skalk. Perhaps just a minute or two. If anyone has a question, they can raise their hand or put it in the chat box. It doesn't look like anyone is typing at the moment, Skalk. So no raised hands either. Right. With that, I think we can call it a day. Thank you very much. Thanks so much for your time and insights. We do have another one, a comment on Bavaria bassiana. Please.
Should I comment?
Yes, please.
Yeah. My wife and I did build Bavaria broadband initially for the banana weevil control. So we are quite familiar with these products. There's pros and cons of a product like Bavaria. Obviously, the big issue is the UV sensitivity. But if you look at what we've said is that your biggest or the area of the macadamia tree where these moths prefer to oviposit is deep inside the tree. Those are probably also going to be the areas that is going to be pretty shaded and screened from your UV rays. So Bavaria, and for that matter, your virus products is actually it's actually very good. I think there's a very big chance that you'll get good control with these products. Under normal circumstances, I think you would. These products are very short-lived, but under the conditions where these moths occur, I think it's a very reliable way, a very likely way to control them. And it will also integrate very nicely with your parasitoids and also with your mating disruption products.
Thank you, Skalk. I see we have 3 more questions. The one is, are there any products that target the pupae phase, potentially the use of EPNs?
Yeah, this is something that we have discussed, and I think it's something that will have to be researched a little bit more thorough. I spoke to some. I'm not going to say who, but I spoke to some people that has done their PhDs and has done a fair amount of work on these moths. And what they do say is that in the pupal stage, and this makes a lot of sense, that the pupal cases do secrete a lot of antimicrobial products because they have to be protected when they are in the ground. And that these antibiotics in the pupal cases can limit the effective use of EPNs, and the usage of EPFs was suggested, but I think the same case could be made for that. It would be interesting. Yeah. I think there's a soil treatment for these guys would absolutely make a lot of sense, as they do in citrus. But yeah, so at this moment, somebody with more knowledge, maybe what's happening on citrus. It will be interesting to hear comments if it's actually the pupae that are controlled, or the final install larvae. I'm actually not sure about this one, to be very honest. So yeah, I would like, if somebody has comments on this, I would like to know.
Thanks, Skalk. We'll move on to the next one that says, have you encountered any non-specificity of ferrolures as used in delta traps for MNB and or FCM? In areas where this happens, what would you recommend?
Yeah, we do get a lot of bycatch. It did happen in the study of Marinus as well. And I can tell you that I'm involved with avocados and macadamias now up in the northern bits of Africa, and some of the products that are available there is a lot less pure than the ones we have in South Africa, and the bycatch on some of that is really horrific. We are dealing with a dynamic system, Alriza. It is changing, and yeah, there's not much one can do at the moment. Yeah, if you do get bycatch, of course, then one will have to look at the product, the purity of the product. Has something changed there, or hasn't it changed? But you, as an end user, are unfortunately very limited to what you can do. But yeah, there's not much one can do, unfortunately. Yeah, apart from removing the bycatch and just counting the real McCoy. I hope it answers the question.
Thanks, Skalk. Makes sense. Then another one, have there been studies on the competition between the different Lepidoptera species and the impact if one is under better control than others?
That is a very good question. And that is where we should focus our research on. There's clearly, when I moved into the Lowveld, it was false codling moth überall, and that pattern has changed. Either the pattern has changed, or we are monitoring it more clearly now. I don't think. I think the pattern has changed, and we need to understand what drives this competition and what makes certain of the moths win and come out as better competitors than others. This will be very important to drive our control of these insects going forward. And it's going to be one heck of a study, but if one focus 20 years ahead, and not just the next year, I think this is a very, very important question, and this is something that we as an industry will have to give a lot of attention to.
Thanks, Skalk. Okay, and one more. With chlorantraniliprole removed for use on tree nuts, what would you recommend as the next best option to use?
Chlorantraniliprole is a very, very good product, and yeah, I've used some. I don't want to choose between other products. I personally have used methoxyfenozide with great success. Reason why I say that is because the environmental profile A, and B, because it also has a moderate effect on the eggs. But really, I must be honest, emamectin is a good. All the other products is chlorantraniliprole was really the go-to product. It's a soft product, and yeah. If you ask me as personally, I probably would look at methoxyfenozide at the moment. But honestly, yeah, it's going to depend on the situation that one is in.
Excellent. Thank you so much. I think we don't have any further questions at this stage. Thank you very much for all your inputs and your presentation. I think it was very valuable. We really appreciate it. And with that, I think we will sign off. Thank you very much.
Thanks a lot.
Have a wonderful day and weekend. Thanks, everyone. Bye.
Thanks.